So for too long, in my view, the scientific community has been focused on the dark side of our evolutionary heritage, on our capacity for selfishness and tribalism and violence and cruelty and mendacity. And I think the bright side has been denied the attention that it deserves. For our species has also evolved to be good and to manifest wonderful qualities like love and friendship and altruism and teaching. And I think these good qualities must have outweighed the bad, or we wouldn't be living socially in the first place. If every time I came near you, you filled me with lies, or injured me, or took my stuff, or killed me, I would be better off living apart from you. So therefore, the benefits of coming near you must exceed the costs. And across evolutionary time, that necessarily must have been the case, and I hope to persuade you today, was actually the case. In fact, these good qualities must have outweighed the bad. And our species has evolved to make a particular kind of good society for ourselves. Now, we evolved to live not only in groups, but rather in a very particular way, equipped with a very particular set of innate capacities. We're not simply like a group of zebras or crocodiles or ants massing, right? We don't just form aggregations of individuals. We form particular social structures of individuals. And we manifest this social ability from very early in life. Many have argued, for instance, that one of the primary functions of play in childhood is simply to prepare us for living together. Children practice making miniature societies. Now, what kind of evidence could we use to ascertain the kind of social order that comes naturally to us, that we are universally predisposed to make? If you were a mad scientist, the kind of experiment you would love to do is take a set of babies like that wonderful little baby right there that as soon as came into the audience, I wanted to go and grab that baby. I was like watching that baby. What you would want to do if you were a mad scientist is take a bunch of babies like that, heaven forbid, and put them on an isolated island and somehow contrive to have them magically be raised on their own and grow up to be adults, and then come back 20 years later and see what kind of social order they made. What kind of society did they make, untutored by anyone else into how to live together? Now, of course, and you can think about this in the same way you think about bird song. Many birds make a characteristic song innately, even raised apart. Some birds, you may or may not know this, some birds are taught how to sing by their prior generations of birds, but some birds, even if raised in isolation, sing the characteristic song of their species. So my question is, what's the characteristic innate society of our species? Now, of course, it would be impossible, cruel and unethical, to do the kind of experiment I just outlined, and it's been called the forbidden experiment. But such an experiment has been contemplated or even attempted by various monarchs who have typically been interested in what sort of language comes naturally to us. So all of these rulers and others are asked themselves the scientific question, if humans were raised apart from language, what language would they speak innately? So they contrived variants of this experiment which involved taking a couple of babies and having them raised by mute shepherds up in the mountains to see, okay, if they came back years later, what language would they speak? But we clearly can't do this. And actually this monarch here, James IV of Scotland, was interested in what language Adam and Eve spoke. So he tried to do this experiment, and the story goes that when he came back years later, the two now grown babies spoke passable Hebrew, was the allegation. But we clearly can't do this. But we might ask ourselves, or are there any proxies for that occur naturally? And there are a number of possibilities with respect to such natural experiments. For example, consider the idea of shipwrecks, where a group of people are thrown together without intending it and left to somehow make society anew. Out of over 9,000 shipwrecks that occurred between 1500 and 1900 during the European exploration of the planet, The Asian exploration of the planet was much more restricted to close to the coast. There were very fewer excursions far from Asia, leaving aside the Polynesian expansion, which weren't shipwrecks. It was a deliberate exploration by and large. Out of the 9,000 shipwrecks that occurred between 1500 and 1900, I was able to identify 20 where the castaways numbered more than 19 people and where they were stranded for at least 2 months. And they're shown here on this map. And I took all available records regarding those wrecks, the sort of the logs left and the journals kept by the isolated guys, archaeological excavations of the wreck sites to see, for example, how much inequality did they manifest? Did they have separate quarters for the crew and for the officers, or did they have one quarters? Was there evidence that they worked together to dig a well? Like, you can't dig a well by yourself. A group of people have to work together to dig a well. So that would tell us something about how the society that these people made was functioning. And so I studied all of this in detail. And one particularly powerful pair of cases involved 2 crews that were stranded. This is the South Auckland Islands. This is south of New Zealand, north of Antarctica. And in the same year, in 1864, 2 different wrecks wrecked. One crew wrecked here, and one crew wrecked here on opposite sides of the island. And they had very different fates. They never bumped into each other. It's almost like the perfect natural experiment. On the south of the island, the crew of the Grafton wrecked. And 5 men made it ashore, and they lived there for 2 years, and they all survived, and they made it off. On the northern part of the island, the Inverco wrecked. 19 men made it ashore, and all but 3 of them died, and there was a little unfortunate episode of cannibalism involved as well. So very different fates in those 2 wrecks. And part of the reason for that, I argue, is the different ways the wrecks began. When the Grafton crashed, wrecked onto the island, the captain of the Grafton had a high fever and was in his cabin. And 4 of the men made it ashore, but the captain was in the wreck about to fall under the water. And they contrived to set up a rope line and, at great personal risk to themselves, save the captain and bring him ashore. So that wreck began with the saving of a life. In the Inverco, the 19 crew made it ashore, and they were at the bottom of cliffs, very similar to the kind of topography that's here in Hawaii, sheer cliffs coming down. There was a little tiny bit of beach. The 19 men made it there. One of the men was injured, and they abandoned him to his fate, and he died. Very different beginnings, very different trajectories of these 2 wrecks. Still, the crew of the Inverco was able to build this hut. These are all drawings taken from one of the journals that was published in the 19th century. Worked together and survived for 2 years before they were able to make it off the island successfully. And I also looked not only at unintentional communities like shipwrecks, but at intentional communities, such as 19th century communes, where people deliberately set out to remake society, possibly in a new way. We have records of this going back to Roman times. For thousands of years, people have said, society's screwed up, let's go try again, and go and pull apart and try to make a new society, always invariably either reverting to the traditional kinds of societies, or if they try something too radical, falling apart and not succeeding. And actually, periods of efforts to live differently, there are these periodic spikes, and I think we're at the beginning of a new spike for various reasons we can discuss later if you're interested. So I looked at intentional communities like the Brook Farm Commune, for example, or the Shakers and other communitarian movements in the United States, or 20th century communes as well, or kibbutzes in Israel, of which there are many fantastic, interesting examples, or at settlements of scientists in Antarctica. Every year, a group of about 30 scientists winters over in the Amundsen Scott Station, the most isolated place you can get on Earth. Nobody can come to them for 8 months. They're there for 8 months all on their own. What kind of social order do those people make? New people every year on the South Pole. And I also looked at online worlds. You would think, in principle, in online worlds, we could make any kind of society we wanted, right? Unfreed from any constraints that we might have in the past. And at other examples, such as nuclear subcrews, or Latin American prisons, or miners stranded deep beneath the earth, or at the communities formed by displaced persons in the wake of natural disasters. And finally, I've done experiments in my lab using some kind of software we've developed that allows us to create temporary artificial societies of real people. Tens of thousands of people have been recruited by us online, and then we experimentally manipulate the kind of social order into which they are dropped. Like, how are the groups structured? How much inequality is there? We can manipulate those things and then test ideas about social order experimentally. And this has allowed us to probe deep questions about the origins of sociality and how and why we go about making societies. And what I found from all this work is that there were some deep and fundamental principles that constrain us to only one way of being social. And I'd like to illustrate this by reference to a famous example of the world of all possible shells. In the 1960s, paleontologist David Raup at the University of Chicago became fascinated by shell morphology and whether it was possible to unify the world of shells into a single equation. We've all seen shells or different shapes of shells, but maybe there's something deep and fundamental, some simple way in which all shells can be defined by one equation that could yield all the various forms of shells. And he devised the following way of thinking about this, arraying shells in a three-dimensional space that he called a morphospace. So there are three parameters here that he had an equation with three parameters, and this paper is a famous paper, and it spawned much subsequent work. There were three parameters that described this equation. First, there was the distance, which is the y-axis here. So this is the x-axis, this is the y-axis, and this is the z-axis. And the distance you can think of as a parameter that describes the tightness of a coil, like a coil of stamps. You know when you have a coil of stamps in your drawer, it can be very tightly coiled or kind of loosely coiled? So that's one parameter that is described in the equation. Another parameter, and so that's like how the rate at which, if you look here, the rate at which the coil sweeps outward. You know, like is it sweeping out or tightly or loosely? Then there is the translation rate here, and that you can think of as the rate at which the coil moves up and down the z-axis like a slinky, right? So one is the tightness of the stamp coil, the other is the slinky. Is it a compact slinky or is it a loose slinky? And last, the expansion rate is the rate at which the aperture in which the animal lives expands. Is it like a tunnel, so it doesn't expand, you just go straight down, or is it like a cylindrical tunnel, or is it like a cone? So as you go further and further in, it starts really wide and then gets narrow, or it starts sort of this way and gets narrow. Those three parameters could define the world of all possible shells. You could imagine, just with those three quantities, all kinds of shells. But what he found was that all shells that exist in the earth, or that had ever existed, were only found in the gray regions of this morphospace. They were restricted to a small part of the morphospace. So many types of shells that were theoretically conceivable will nonetheless never have existed. Well, imagine we define some axes for societies, like how friendly the societies are, or how cooperative the societies are, or how unequal the societies are, or how hierarchical the societies are, or how prone they are to social learning, or to playfulness in their children, for example. Imagine we define such axes. What we would find if we did an analogous exercise is that all observed societies occupy a small portion of the morphospace. So we look around the world and we think societies are so different, but it's a delusion. They're not so different. Deep and fundamentally, these societies are a small fraction of all possible kinds of societies that might at least theoretically exist. And the question is why? Why is that we are predestined to make a particular kind of society, no matter who we are or where we are in the world? The question is why, and the answer is a natural selection. In fact, the key capacities that we humans have that universally characterize our societies and that we need so as to be able to form a functional society are these 8 that I call the social suite: identity, love, friendships, networks, cooperation, in-group preference, mild hierarchy, and teaching. And I call this the social suite, like an assemblage of traits that we must have and that are present in every society around the world. And these traits are genetically encoded attributes shaped by natural selection that we express among ourselves, not as isolated individuals. So one of the crucial things about all of these traits is that they're inter-individual, right? You can't cooperate with yourself. You have to cooperate with someone else. You can't befriend yourself. You have to befriend someone else, okay? You can't have you can't have mild hierarchy with yourself. Mild hierarchy is a property of groups. So all of these are properties of groups that we must express and that we do express societies the world over. Indeed, they are adaptively useful, even crucial for making a society. And natural selection has shaped not just the structure and function of our bodies, as you all know from high school biology, and not just the structure and function of our minds and hence our behaviors, but natural selection has also shaped the structure and function of our societies. And these traits are universal, and they are seen in every society. Let's just look at a few of them today. Now, one of the greatest paradoxes about mammalian social life is that the capacity to be a distinctive individual is actually an essential predicate for living socially. The ability to express and also to recognize individuality only evolves when it is beneficial, and these two capacities are extremely rare in the animal kingdom. If you do not want others to attack you mistakenly, or to forget that they had sex with you, or to provide parental care to a different child and thus neglect you as an infant, or to neglect to repay your kindness, or to forget where they left off your lesson in how to do something complicated, then it is advantageous to have some way of signaling, this is me, not someone else, and to have other people recognize that signal of who you are. You see, social interactions require that we have an ability to communicate our unique individuality. And in our species, we use our face for this purpose. Their unique appearance and our cognitive ability to detect such a difference is an evolutionary luxury. So all of your kidneys, in principle, look and work the same. But for your faces to do their job, they have to look different. Every face has to be different for it to do what it's supposed to do. And not only that, and it's an evolutionary luxury, like why don't we all have the same face? Or maybe we could have men have one face and women have another. Or we all have the same face while we're children and then transition to the adult face, right? There are other ways we could have faces, but that's not what we do. Each of us has a unique face. And not only that, but we can recognize the faces of others, which takes a huge part of our brain. I can look out at you and instantly tell each of you apart from the others. In fact, I can make inferences about who's siblings with who just by looking at you. Oh, they must be related, right? So this is a huge part of our brain that is devoted to this functionality, communicating our individuality and being able to detect it. And it is, in fact, an evolutionary luxury. Other animals don't do this. Well, some do. We'll get to that. But we do. And this comes about, the use of the face to communicate identity, comes about in part because of the fact that variation in any one trait in our faces, like the width of your nose and the height of your nose, or the shape of your ears, or the angle of your cheekbone, and so on, each of those metrics in your face is completely independent of variation in the other traits. And so therefore they are endlessly recombinable. For example, if you look at your hands, imagine your hands. If you look at the width of your hand, this is in a large sample of military conscripts whose bodies were measured. If you look at the width of a man's hand or a woman's hand, a person's hand, and the length of their hand, there's a correlation between those two. So information about one contains information about the other. They're correlated. But if you look at people's noses, there's no correlation. They're totally independent. And that means you can have many more kinds of noses than you can have kinds of hands. You should have the intuition by looking at data like this. And in fact, every attribute of our faces, every single one, is independent of the others, which gives us the variety we need to all have different faces that then other people can interpret. And there's new research that's revealed the great genotypic variability that underlies our facial phenotypes. There are regions of the genome which are highly variable, like our region having to do with olfaction and with immunity, but the region having to do with how the kind of face we have also has a tremendous amount of variability. Love is another universal trait. Our species is unusual among mammals in that we don't just have sex with our mates, we bond with them. We form a sustained emotional attachment to them. We love them. Now, love is not essential for mating, as I'm sure all of you know, but we do it anyway, in part because it helps us to raise our young. One of the arguments about the evolutionary origins of love between partners is that it's advantageous in the prospect of raising our young. And actually, there's some interesting, we can talk in the Q&A, some interesting theories about how the evolutionary antecedents for love in males and females may be different, actually. We can come back to that, sort of interesting. And even though marriage systems vary around the world, as shown here, this fundamental fact of human bonding and love does not vary. Now, we don't just mate with each other. As I mentioned already, we befriend each other. And humans are unusual as a species in that we form long-term, non-reproductive unions with unrelated conspecifics. That's like a scientific way of saying we have friends. And this is seen in every society. There is no society, there's some wrinkles that I discuss in the book, some possible exceptions which are not really exceptions. Every society has friendship. And the key attributes of friendship are also quite consistent around the world, and they are manifested early in life. For example, they include mutual aid. We help our friends, and they help us. This is a fundamental feature of friendship. And positive affect. We feel good in the presence of our friends. You guys take it for granted that you feel good in the presence of your friends, but why? Why did evolution shape your body, your mind, and your physiology so that you feel good when you're in the presence of your friends? Your blood pressure goes down. You sweat less. You calm down. You enjoy being in the presence of your friends. That's a physiologic adaptation that has been shaped by natural selection, which makes you want to have friends and benefit from it. And there are other traits as well, which are very common in friendship in cultures examined around the world. Now, my lab has fanned out around the world to study friendship and distinctly to map the social networks that friendship gives rise to. For instance, in one study, we compiled a photographic census of adult Hadza. So there are only about 1,000 of these people left. The Hadza live around Lake Eyasi in Tanzania. They live in the ancestral environment of all human beings in the way that we all did into the Pleistocene. They hunt and they gather for their food. They sleep out under the stars. They have very few material possessions. They're a very egalitarian society. And working with the ethnographers of the Hadza and the Hadza themselves, we compiled a photographic census of all living adult Hadza, 1,000 Hadza, and we printed it onto posters. And my postdoc, Karen Apicella, took it into the field and just waited around Lake Eyasi for some Hadza person to walk by, because you can't make an appointment with a Hadza person. You have to just wait till you bump into one. So she just stood there, and someone would actually, excuse me, could you tell me who your friends are? And they would point to their friends, immediately understood the task, right? And off that person went, and she waited another week for another Hadza person to walk by. Who are your friends? And so on. And we painstakingly collected data to map the social networks of the Hadza. And it turned out that their patterns of friendship and social interaction are just like ours. That is, despite the fact that in the intervening 10,000 years, if the modern Hadza can be used as a proxy for the Hadza of deep antiquity, despite the fact that in the last 10,000 years, we've invented agriculture, we've invented cities, we've invented telecommunications, the networks we make are still the same. It's just like theirs. And my lab has asked people to identify their friends in a number of ways, and we have mapped social networks in many places around the world. For example, in villages everywhere, we've mapped networks in Honduras, in India, in Uganda. We've mapped networks of the Nyangatom in Sudan. We've mapped networks in the United States. Wherever you go, every dot here is a person. Every line represents a relationship between two people. Just looking at these three village networks, you should be able to see that there's something deep and fundamental that's similar wherever you go around the world and you map social interactions. Now, there's some differences too, but the fundamental picture is one of similarity. There's a startling consistency and universality to network structure. Very pertinently, however, elephants and dolphins also have friendships. And their networks looked very similar to ours, mathematically speaking. This is an elephant network. Every dot is an elephant, and every line represents a friendship between the two elephants, which can be quantified by the amount of time those two elephants spend with each other. And like us, the elephants have preferences. I want to spend more time with you and less time with you. And elephants are just like that. And you can map the networks of the elephants. And what's interesting is our last common ancestor with elephants was 85 million years ago. And that animal was an animal that didn't live socially. And so the elephants have independent of us, evolved the capacity for friendship and networks just like we did, completely separately from them. Natural selection has independently come up with this very uncommon practice. Now, this is known as convergent evolution, when organisms independently evolve to be similar, solving similar challenges in similar ways. This is a very famous example of this. These two cute creatures shared a common ancestor over 200 million years ago that looked nothing like this, and yet they independently evolved such similar ways of being in the more recent past. So on the left is an echidna, a marsupial from Australia, which I was privileged to see once in the wild, and on the right is a hedgehog, a much more common animal. Now, we usually think about this process with respect to physical features, but it's not limited to physical features. And this observation about convergent evolution of friendship and social networks leads us to another paradox. Because to the extent that we can resemble animals in our propensity for friendship and other traits like cooperation, we gain insight into our own common humanity. In other words, if we humans have friendships similar to animals, then we humans have friendships with each other. We are similar to each other. Ironically, when you find a trait in humans that's also present in animals, it highlights the universality of that trait in ourselves, the fact that it's everywhere, and should, in principle, could provide a basis for mutual understanding and a kind of respect for our common humanity. Because if we can share the capacity for friendship with elephants, we can surely share it universally with each other. Yes, sweetheart. Now, the actual structure of these networks we make matters to our life experience. The fact that the network pictures I've showed you look a particular way, it turns out that structure is highly relevant to the fate we have in life and to the way we experience our lives. Think about these two objects. As you all learned in high school chemistry, and are maybe still learning, they are both made of carbon. And on the left, you have graphite, which is soft and dark. And on the right, you have diamond, which is hard and clear. And there are two key intellectual ideas here. First of all, these properties of softness and darkness and hardness and clearness do not inhere in the carbon atoms. They are not properties of the carbon atoms, they are properties of the collection of carbon atoms. And second, which properties you get depends on how you connect the carbon atoms to each other. Connect the carbon atoms one way, you get one set of properties. Take the same carbon atoms and connect them another way, you get a completely different set of properties. And it's the same with human groups. You take a group of people and you connect them one way, they may be really nice to each other. Or take the same people and connect them a different way, and they'll be really mean to each other. That means you see that niceness and meanness are not just properties of individuals or some kind of averaging across individuals. It's the structure of interactions that can give rise, for example, to these sorts of properties. It's the ties between people that make the whole greater than the sum of its parts. New properties, such as cooperation, can emerge because of the connections, because of the ties between people, and not necessarily because of the people themselves. So it's not just what's happening in the people around us that matters. Our experience of the world depends on the actual structures of the ties around us, near and far. And these collective social structures can have emergent properties, just like the carbon example. In other words, you can connect people and you can have softness and darkness, or connect them and have hardness and clearness, for instance. And those properties are emergent properties, which once they come into existence can affect the individuals that are the constituents of that society. The social order, which we are pre-wired to make, matters. Now, this phenomenon, this idea of emergence, which I just mentioned, has other consequences. And this is a subtle idea I'm going to try to explain now, because you see the social suite has come to be shaped by natural selection in a variety of ways as a result. You see, we make these intricate social worlds for ourselves, and these worlds in turn affect us as much as we affect them. Now, one set of ideas regarding the mechanism for this relates to a notion of what I call an exophenotype. An exophenotype is a phenomenon whereby genes guide animals to create things outside their bodies. For example, consider a beaver dam. A beaver makes a dam, and the beaver modifies its environment, right? By blocking a little river, it creates a flood behind it, and when it creates that flood, and you reshape the river, now the beaver has exercised a selection pressure on all the other plants and animals that live in that area. As much as, right, the beaver has modified its physical environment, and now the fishes will be different because the fishes aren't moving in rapid rivers anymore, they're moving in stagnant ponds, and the plants will be different. Okay, fine, but there's something even more amazing that the beaver has done. The beaver has modified the environment not only of other animals, the beaver has modified the environment of itself. You see, now that the beaver dams the river, the beavers could evolve to take advantage of that. For example, beavers with bigger lungs can forage underwater a greater perimeter. And beavers with bigger lungs that can forage a greater perimeter might make bigger dams. So now we have a situation in which the beaver, encoded within itself, has the rules to change its environment, which when it changes the environment, feeds back and exercises a selection pressure on the beaver, changing the beaver. So you get this feedback loop between the beaver and the environment that it makes and itself. And there are many examples of these exophenotypes. Spider webs, a classic example is these birds in Indonesia that make what are they called? Barrows? No, they're called, I'm blocking on the name right now. But there are many animals that make things outside their bodies that then affect them. And you see, analogously, humans have evolved to manipulate the social world around us. We don't knit sticks together to make a dam. We knit people together to make a network. And then we proceed to live in that network. And that network, you see, can then feed back and change the kind of people we are. Friendly people make friendly worlds, and friendly worlds advantage friendly people. And once you start down the path, you get this feedback loop. And it happened to us, and it happened to elephants, whereby we make these kinds of worlds for ourselves. And same with cooperative people. Cooperative people make cooperative worlds, and cooperative worlds advantage, there's some wrinkles there, advantage cooperative people. We make particular sorts of social worlds, and those who can do well in such social worlds grow more numerous, as do their genes. Now, the traits that make up the social suite are mutually supportive. Many of these play roles in the others. For example, identity is clearly important. You need to know who your partner is to love them, right? They can't be interchangeable. You have to be able to track them across time so you can remember them. Same with friendship. And friendship is important for networks. And all of these are important for cooperation. I didn't discuss today in-group preference, which is the fact that people tend to prefer the company of others that are part of their own group, which is like one of the sort of unfortunate realities about our species, but I discussed that in Blueprint. Mild hierarchy is another thing that we manifest. And teaching, all of these qualities, cooperation, for example, is crucial in teaching. If you're to teach someone else something, it's a kind of cooperative act where you're giving something, an altruistic gift you're giving to someone else when you share knowledge with them, for example. And I want to say now just a few words. I have about 3 more ideas to go through before I end. I want to say, each idea will take several slides, so don't get your hopes up just yet. I want to say a few more words about teaching in particular, because it lies at the root of our capacity for culture. Now, most animals learn, right? Animals learn through contact with their environment. A little fish in the sea can learn that if it swims up to the light, it will find food there, right? So most animals learn independently by contact with the environment. But some animals learn socially, okay? For example, you can learn independently that if you put your hand in the fire, it burns, That's independent learning. Or I can watch you put your hand in the fire and see that you've burned your hand, and I gain almost as much knowledge, and I pay none of the price. So that's very efficient social learning. Or you and I go into the forest and you eat red berries and die. You've learned a lesson, you're dead, but I can watch you eat the red berries and learn not to eat red berries, okay? So social learning is extremely efficient. And some animals do social learning, but we do something even more remarkable, which is very rare in the animal kingdom, which is we affirmatively teach each other things. I teach you to build a fire. I don't just passively mimic you. You know, you're not just doing something and I observe it. You teach me to do something. You set out to teach me how to build a fire, for example. And this affirmative teaching is exceptionally rare in the animal kingdom, unlike social learning. And this ability allows us to cumulatively create and store knowledge and transmit it across time and place. It allows us to be cultural animals, in other words. And the knowledge that we transmit across time and space in the form of teaching is a fundamental driver of economic growth. In other words, all of you, all of us, we were born today in this century, and when we were born, we inherited all the gifts of our ancestors. All of the animals had been domesticated thousands of years ago. Ways of building canoes had been invented by prior people, and it was given to us. It would be like if I just gave you a huge amount of money right now as a gift. That's in essence what happened when you were born. You were given a gift. Newton had already invented calculus, and you got it for free. You were taught it in high school, right? By the way, Newton invented calculus over the course of a year, which is the pace at which we currently teach it. And he kept the mathematics secret for 20 years. It was his private mathematics. Can you imagine the genius of that guy? He invents a whole branch of math, which he uses for his personal mathematics. For 20 years, he keeps it secret until he hears Leibniz is going to publish it. But anyway, so you're just given this. All the metallurgy had been invented, the pottery, the fabrics, all of this stuff. The land had been cleared, the farmland. All of this stuff our ancestors had done, and they were gifts that were given to you. And the reason you got those gifts was because of our capacity for teaching, to accumulate knowledge and transmit it across time and across place, right? So knowledge spreads laterally in humans and spreads temporally in humans. And it is, in fact, there's a big debate in economics about what is the most fundamental and deepest driver of economic growth. I remember having a discussion about this once with a very famous Nobel laureate by the name of McFadden, who invented some econometric techniques. He was famously very laconic. He didn't speak much, and I was seated next to him at a dinner, and I brought up this topic trying to make conversation. I was a young professor, and I said, Professor McFadden, what do you think? You think the driver of economic growth is this or that or whatever other? And I put all these theories on the table, and he listened patiently to me, and he said, no, he goes, I just think people like to shop. It's a very telegraphic way of articulating another fundamental driver of economic growth. But anyway, now the reason I'm mentioning this, so apart from the interest in teaching, is that this capacity for teaching and the capacity to make culture in turn shapes us even more. Our genes affect our capacity for culture, and our culture affects our genes. This is a further distinct idea from the sort of innate formation of social networks and exophenotypes I just mentioned. So it sounds similar, but it's not. This is a different idea, because we're not obligated to make any particular kind of cultural product. The beaver must make a dam. We must make social networks. But the cultures that we make are infinitely variable. We can make any kind of culture, but not any kind, we can make many kinds. And the kind of culture we make, however, also feeds back to affect our genes. Now, the best example so far of how macro-historical cultural developments could affect our genes is the evolution of lactose tolerance in adults. Now, all of us, the lactose is the is the sugar in milk, and lactase is the enzyme in our bodies that allows us to digest lactose. Prior to 10,000 years ago, human beings had lactase when they were babies, and then they stopped making lactase when they were weaned. Why? Well, because they never needed it anymore. Never again did they ever encounter any milk after you were weaned. You had milk when you were a baby, then you were weaned, and you never saw milk again. Therefore, there was no reason to incur the cost of making lactase in your body. And then what happened? Multiple times between 3,000 and 9,000 years ago, principally in North Africa, but not only there, also in the Asian subcontinent and elsewhere, human beings domesticated milk-producing animals like camels and goats and sheep and cows, for example, and therefore changed their environment. This technology we invented modified the environment because now there was milk in the environment. There wasn't milk before in the environment, now there was. So those humans among us who had mutations that allowed us to have lactase persistence into adulthood so we could still drink milk as adults, those humans now gained some advantage over the humans that didn't have lactase because they had another source of calories and a source of clean hydration in times of spoilage of the water. They could drink milk. And therefore, this created a selection pressure on humans so that now the majority of people on the planet can drink milk into adulthood with relatively few problems. Something we humans did changed the environment and therefore exerted a selection pressure on our genes and changed the course of evolution in historical time, in the last few thousand years. And there are other examples of this which are extraordinary. Everything from like tonal languages, or whether tonal languages, speaking a tonal language, which is a cultural invention, speaking a tonal language like Chinese, for example, does that, for example, across time, reshape the speech capacities, the musical abilities, for example, of people who've been raised in that environment, or the settling of the Himalayas. Humans decided to go settle the Himalayas, and the people that live in the Himalayan mountains have different oxygen, can process oxygen differently in their bodies, okay? Again, a cultural change that redirects our evolution. I bring this up because I think global warming is an example like that. Right now, we are changing the global environment with things we're doing. The humans that are alive in, forget 10,000 years, I think the humans that are alive in 30 generations, so maybe between 1,000 and 3,000 years from now, will be different and be different genetically than the humans that would have been alive had we not warmed our planet, okay? So this is extraordinary. Our ability to create cultural artifacts, invent new technologies, changes. One final example is the fact that we are all getting more myopic. And I think part of the reason we're getting more myopic is because of medieval lens grinders. Like I would have been eaten by lions and all my progeny would not exist 10,000 years ago. But now, because of medieval lens grinders, I have glasses, I survive, I pass on my myopic genes. And also modern medicine. Many people that would have died but for modern medicine survive to reproduce. And so in some ways, the bodies that humans have over time might be different than the bodies they otherwise might have had. So our genes and our culture are in a conversation. And it's a remarkable conversation. It doesn't happen, just to be very clear so I'm not misunderstood, it doesn't happen over our lifetimes or over centuries. It's over millennia and eons these effects take place. Now, there are a number of applications of all these ideas about how we evolve to make societies, and I'd like to focus on one illustration before I close. For instance, we humans, in addition to the example of global warming, we've also begun to modify our social systems with artificial intelligence. We're going to be increasingly adding machines, such as driverless cars and automated checkout clerks and warehouse robots and digital assistants, and adding also autonomous agents, such as online bots, to our social systems. So these machines are going to act in human-like ways on a level playing field as if they were human in what I call hybrid systems of humans and machines, little societies that have people in them but also have sprinkled in some machines. And these hybrid systems of humans and machines will offer opportunities for a new kind of social artificial intelligence. An AI might act socially or might also affect our social organization. Now, one example I've given repeatedly to certain subgroups, so those of you that have already heard this, please bear with me, but most of you haven't heard it. One of my favorite toy examples of this is the idea of an Alexa. So when the manufacturer manufactures an Alexa, they manufacture it so that it has a pleasing interaction between you, the human, and the machine, right? So for example, you don't have to say to the Alexa, excuse me, Alexa, I'm really sorry to disturb you. If you don't mind, could you please tell me the weather tomorrow, right? That would be ridiculous. If the machine was, if you had to engage in that kind of elaborate politeness to talk to a machine, you wouldn't buy it, right? So the machine is obedient. You just say, Alexa, weather, and it tells you the weather, okay? Which is fine in terms of the human-machine interaction. But then you bring the machine into your home, and your kids use that machine, and they learn to be rude, and then they go to the playground, and they are rude to other children. So the machine is changing human-human interaction, right? It's a cultural thing that we are doing that's reshaping the way we interact. And this is deeply interesting to me, and something we are actively investigating in the lab using a variety of applications and experiments. And in fact, what my lab is doing is we are working not to develop super smart AI to replace human cognition, like ChatGPT and all of these examples everyone is talking about. We're not trying to develop super smart AI to replace human cognition, but rather we are developing what we call dumb AI to supplement human interaction. And the AI can afford to be dumb because it's in the midst of smart humans. You can think of dumb AI as a kind of social catalyst. All we need is just a little lubrication. We got a group of people, they're not working well together. Maybe we can add a little dumb AI to that group, and now they'll work better together. That's what we're trying to do, change human-human interactions through the addition of machines to these systems. Can simple forms of AI, when added to groups of much smarter humans, help the humans to help themselves? And we think the answer is yes. And let me give you results from a couple of experiments that we've done. This is one experiment involving simple AI that we have deployed to exploit our understanding of the evolutionary blueprint for human groups. So given everything I told you, we said, okay, let's take that to the lab and see if we can use that knowledge to influence human groups. Cooperation in human groups is challenging. It's difficult to get people to cooperate, and various mechanisms are required to sustain it, although typically it decays with time. So groups will start cooperative, and over time, as some people within the group are mean or take advantage of others, then everyone degrades to be abusive and selfish. So in this experiment, what we did is we dropped people into a network with this structure. So we defined this structure mathematically. Imagine that there are cups, imagine that there are empty cups on a table, and we connect the empty cups with strings, and now we drop humans in each of the cups and introduce them to the other humans in the other cups to whom they're connected. And we say, okay, now you're going to play something called a public goods game that Ruben knows a lot about, that you're going to play a public goods game, which means you're going to play a cooperative game where you need to be nice to others and then they'll be nice to you. And the nice cooperative people are the blue people, and the people that take advantage of their neighbors are the red people. And what we find is, in this experiment, is in one branch of the experiment, over time, by the end, most of the people are defectors. This is like, the reason for this is like, the example for this, I've given so many examples from high school. My whole research agenda is driven by my experience in high school. Remember in high school, when you were assigned, the teacher said, okay, you four are going to do the project on volcanoes, and you four are going to do the project on dolphins. And you're like, oh my God, I got assigned to 3 losers. And your choices are now, and you're all going to be graded together. And your choices are now to do all the work, and then your friends get the A grade because you did all the work. And then you're resentful because you did the work and they did nothing. Or you say, I'm not going to do that, and I'm not going to contribute, and then you all get Fs. Those choices suck, right? Like, you don't like those choices. You want everyone to contribute is what you really want. That's a public goods game. It's what economists call a public goods game. But anyway, so what happens in that type of a situation is when you put people in a group and you give them a challenge like that, is eventually everyone starts defecting. People stop making an effort, and the society collapses. In a different branch of the experiment, however, we added these network engineering bots. We added little bots that did something very simple. They would ping a small subset of individuals and explore their behavior just with locally. They didn't have godlike knowledge of the whole system. They just knew a little bit of local information, and they would tell cooperators, you know, you might want to cut the tie to this defector. Or tell the cooperators, you might want to form another tie to this cooperator. Just a little bit of rewiring in the background, like those, never mind. A little bit of rewiring in the background. And in that type of a situation, we could get the groups to knit themselves together so they're socially much more interconnected and they're all nice blue people, and these defectors have been socially marginalized now where they can do the least damage. And this experiment was just published, recently in 2020. In fact, cooperation rates in the whole group increased from 60% at baseline to 80% by the end. So by exploiting ideas about identity, networks, cooperation, and social learning, simple artificial intelligence can increase the cooperation in groups. Now, we've also begun to experiment with physical systems. This is an example of an experiment in my lab. This was not a humanoid robot, obviously, but we also did an experiment with humanoid robots. So we got a little humanoid robot, and we brought people into the lab, and 3 humans and 1 robot, and they were given tablet computers, and they had to work together as a group, the 3 humans and the robot, to lay railroad tracks from point A to point B. So they were laying track together, and they were trying to create a track line from one point to another. And what we did is we manipulated whether this humanoid robot told dad jokes. So we had the human robot tell just dumb dad jokes that were really corny and stupid, and so we randomly assigned the humans to, sometimes they were with a robot that made very technical statements like, we are on the 5th round and there are 35 seconds remaining, or it would say like some kind of stupid joke like, what's the difference between a robot and a zebra or something? And I don't remember the answer to the jokes, but the point was that we found that when we had a kind of dad joke robot, that these lines indicate the conversation between all the pairs of individuals, and the thicker the line, the more conversation. With a neutral robot, you didn't have as much conversation, but adding this dumb robot that told dad jokes changed how the humans spoke to each other, right? Made it so they were more willing to work together to try to tackle a collective problem. In short, humans can learn to interact better by having bots among them, and not just among those humans who are directly connected to the bots. The bots, as I said, help the humans to help themselves. And we're building on this work to design and add simple bots with artificial intelligence to these situations: coordination, cooperation, communication, evacuation, navigation, and sharing, and many other problems of collective action, ways in which human groups don't work well. Maybe we can add some bots and help them. And my argument is that hybrid systems, which we are going to have, need to respect the social suite if they are to facilitate a utopian rather than a dystopian future. If we don't have the bots behave in keeping with the social suite, it's going to make things very bad. All right, I'm going to close with 2 final slides and 1 final idea. Because our focus today is on the social origins of goodness. Our focus on the social origins of goodness also highlights something else. Most human virtues are social and arise from investment in the lives of others. We do not care if you love yourself, or are kind to yourself, or are just to yourself. We care whether you love others, or are kind to others, or are just to others. We care whether you manifest these virtues to other people. So I'd like to close with a final idea. What accounts for our species' general success in living together in the face of all of our defects and differences? How can we understand the goodness of the social world despite the badness? Now, in theology, this is known as a question of theodicy. How is God to be justified in the face of all the evil in the world? Right? Theologians have been wrestling with this for a very long time. I believe, analogously, that we can focus on what I call sociodicy. And this is the vindication of our confidence in the virtue of society despite its numerous failures, so obvious to anyone. I'm well aware of the history of colonialism and slavery and pogroms and violence and warfare and torture and all the awful things that we do to each other. I'm well aware of that. And yet I still believe that the good outweighs the bad. How are we to explain and understand this? I think this is a problem of sociodicy. And it's in keeping with the Japanese aesthetic philosophy of wabi-sabi, which highlights the flawed beauty of natural and artificial things. Like to a Japanese eye, and to my eye, this is a beautiful bowl. It's magnificent. In fact, it might even be priceless. This bowl with a crack and defects and so on. And this bowl is completely different than the Western aesthetic. Like, at the same time the Japanese are making bowls like this, in Versailles they're making like perfect pottery, a perfectly symmetrical, no chips pottery. The Japanese are making bonsai trees, and the Europeans are making topiary, where they make these perfect pyramids and squares. They trim the bushes, okay? So this is a different aesthetic philosophy, wabi-sabi, which is that you can like something and appreciate it despite its flaws, or maybe even because of its flaws. Now, I think this is a beautiful wall, don't you think? I think this is beautiful. And this is not just idle optimism. Rather, it's the recognition of the fundamental good that lies within us. It's tempting to look at human history as full of abject misery and dysfunction. You can pick any century or millennium and find it replete with horrors. And there was, of course, a dramatic inflection for the better that occurred in the 18th century with the arrival of the Enlightenment in Europe and its philosophical values and scientific discoveries. So beginning in the 18th century, you had discovery of electricity and magnetism and the steam engine and so on. And you had new philosophical ideas about the equality of human beings and democratic governance, for example. And these ideas spread around the world, unevenly, not always applied fairly and to everyone, but eventually they spread all around the world. And as a result, the argument goes, we live longer, richer, freer, and more peaceful lives. But here's my argument. We do not need to rely on such recent historical developments to make the world better. What I've been showing you today is that a more ancient, more powerful, and deeper forces are at work, propelling a good society. In short, the arc of our evolutionary history is long, but it bends towards goodness. Thank you. If I need it, I'll use it.
Thank you so much for this thought-provoking lecture. It was awesome, actually. So before we start the questions, a host of organizations came together to make Dr. Christako's visit to Hawaii possible, and we have all sponsors present, actually. So the main event sponsor are UHERO, thanks to generous funding from HMSA, the Kahala Hotel and Resorts, and the U.S. Department of Economics. The Better Tomorrow series is a joint venture of the Hawaii Community Foundation, Kamehameha Schools, and the University of Hawaii, Manoa. Series sponsors also include Queens Health Systems, the Ulupono Initiative, and Scholars Strategy Network. So thank you to all the sponsors. So students are going to be available with a microphone. If you have any questions, they're going to come to you. There's one over there. And another one over there.
Okay, so an ankle first.
And the baby left before I could hold the baby.
Go ahead. Oh, actually, we need that for the video, sorry.
I'm not allowed to give you microphone. So,
stand here?
Yeah, just stay here, sorry.
so let's start with this guy.
Yes, thank you. First, a brief comment, then a question. What you said about technology affecting us reminds me of Marshall McLuhan, whose name you might remember. We shape our tools, and our tools shape us.
Yes.
But my bigger question was two parts, going backward and forward. Do you agree with some paleoanthropologists who think the Neolithic, the agrarian revolution, was the worst mistake in human history? And going forward, do you think carbon-based life form will exist in some way, shape, or form, even in the worst-case environmental scenario? Thank you.
So in the latter question, you mean, do I think that there's carbon-based life on other worlds?
No, will it exist on this planet in the worst-case scenario?
No, I think it's possible we'll go extinct and all life. I don't think all life will die. I mean, we've been hit by planet-killing meteors in the past, and life survived. So I think humans will be on, not humans, life will be on this planet, I think, for millions of years. It's more difficult and interesting to speculate. There's some very interesting work by paleontologists who speculate that, that life forms on other planets might not look too dissimilar from our own, even if they started from scratch, which is, we can talk about that if you're interested. But going back to your first question, which was about whether the agricultural revolution, which took place roughly 10,000 years ago, although there's a big debate now. So the argument is that we invent agriculture, we domesticate plants and animals about 10,000 years ago, and then subsequently we invent cities. But there's some new discoveries that think that we actually might have invented cities before we invented agriculture, which is a big radical change, these excavations in Turkey right now. No, I don't think that the agricultural revolution was bad for human beings. I think there is a kind of way in which we think of, you know, a kind of fantasy about life, you know, before technology, before agriculture, that imagine that people were very peaceful and thriving and so on. If you go to hunter-gatherer societies, they, if you burn yourself in a fire in a hunter-gatherer society, you die, right? You, in the United States or in modern world, you would not die if you burned yourself. The force of mortality and of violence was very high. They're always, many of these societies are living on the edge of death, actually. Yes, they hunt and they gather. Yes, they don't have to, they work, people have done time use studies. Many of these traditional societies, they're not working, they're not as frenetic and crazy as we are. Okay, maybe they're not working 50 or 60 hours a week, but they're working 35 hours a week to meet their calorie needs. And so I'm in the camp. I recognize there's a debate about this. I know that smart people are on both sides of this topic, but I'm in the camp that thinks that no, the agricultural revolution was a net benefit for our species. Did I answer your question? Yes. Yeah.
Okay, thanks. Thank you so much for the fantastic lecture. I had 2 questions about the social suite. My first question is, how did you decide which traits of human society made it into the suite? You know, for example, was there a potential 9th one that didn't quite make it? And what was the criteria for making it into the suite, and
Yes.
maybe what got left out or what was on the border? And the second question is, how do you, this is a sort of an intentionally naive question, how do you think about the relationship between the psychological qualities of everything in the suite and the social qualities? You know, is it that the social qualities are shaping our psychologies, or the psychologies are also shaping the social side? Of course, both are shaped by genes, but how do you conceive of the relationship between the psychological and the social?
So the first question is a little bit easier, which is that I put everything on the list that met my criteria, which is that something that was expressed inter-individually. So people ask me, for example, about religion. Yes, religion is often practiced collectively, but you can do it by yourself, and you can have religious feelings on your own. And in fact, Jane Goodall has, there's an interesting literature on the origins of awe. All of us have had this feeling of awe, every human being. It's a fantastic feeling when you have it. It can be evoked often by the natural world, you know, the sunshine or great valley, you know, or forces of nature, even violent forces. You know, I remember once being in a lightning storm, and it was just, I mean, just thinking about it right now, it was just an awe-inspiring experience. You know, bang, bang, you know, and you have this recognition of your insignificance, you know, before the forces of nature. And Jane Goodall has described seeing chimps looking at sunsets, you know, as if they were awestruck. And I think, so you can have that by yourself, you know, and then of course we also have awe we can have awe from ideas, like a belief in spirits, for example. But all of those you can do by yourself, right? So everything on that list that I put is something that you need other people to do. And second, that is at least partially genetically encoded, right? So there are things that aren't genetically encoded that many human beings do that are not on the list. So no, there was nothing that was almost made it, but I didn't put on the list. Your second question had to do about the relationship between psychology and the collective properties. I am, of course, interested in psychology. I'm specifically interested in social psychology, but what interests me is really interests me is the sociology of it, right? So for me, the psychology is just like the way we get to the sociology. It's, you know, I have nothing against psychology. Some of my best friends are psychologists, but I think the psychology is the effector organ of the genes, right? So I think the genes shape your psychology, and then through that intermediary shape our social life. So for example, your desire for friendship, the thoughts you have about your friends, your altruistic impulses, those are all psychological traits within you, but they're expressed interindividually. Did I answer your question? Yeah? Okay.
Oh, sorry. You talked about the things that people have done, the clever things that humans have done, like inventing robots and domesticating animals that have affected the social structure and genes. What about ideas, and what about ideologies that people become attached to?
Yes.
That create this tension
Yes.
that we see now in this country, at least? Yeah.
So
say something about that?
one of the most famous examples of that is the idea of monogamy, of social monogamy. So if you look at the history of monogamy and polygamy, principally polygyny, one man, many women, it's likely that in our ancient ancestral past, I'm going to get these dates not exactly right, but this is discussed in detail in the book, up until around 300,000 years ago, we clearly had a polygynous past, and that's partly reflected in the body asymmetry between men and women. The fact that men are bigger than women probably reflects the fact that in the past, men used to fight each other for access to women. And so we like other primates, we had a polygynous past. And then we went through a prolonged period of monogamy as we transitioned to hunter-gatherer bands, and the females in our species were able to adequately provision for themselves. They didn't like the guys that were being too violent. They could just, to hell with you guys, I'm just going to go over here and be by myself or with one man. And we seem to have had a mostly monogamous, these are rough approximations. I'm summarizing a vast literature and compressing lots of interesting details. Probably we were monogamous in our kind of band-like living in the past up until around 10,000 years ago. And then coming back to the agricultural revolution, one of the things that became possible with the agricultural revolution was great economic inequality. Because now all of a sudden you could accumulate resources, especially in cities. In the past, if we were moving around, you couldn't take your wealth with you, right? Imagine if every time you had to move camp, you had to carry all of your huge supply of grain and gold and whatever else you accumulated. It was not practical. But now once we domesticated animals and we could get food reliably in a given location, and we lived in cities and had storerooms and so on, you could accumulate wealth and therefore had tremendous inequality. And coming with that was a reversion to a kind of non-biological but rather cultural polygyny. So we became polygynous again, culturally. But then around 2,000 years ago, initially starting in Athens and then spreading in Rome, we began to adopt a social or cultural monogamy again. It became a practice. Initially, it was mandated by law, and it actually, there are still many polygynous societies around the world. I think over 1 billion people live in societies that practice polygyny, but monogamy was a cultural trait, an idea, if you will. And people like Joe Henrich, and this is discussed in the book, have argued, he's an anthropologist at Harvard. What Joe has argued is that societies that practice monogamy were able to outcompete societies that practice polygyny. That actually polygyny is internally very divisive, because a large fraction of the men within that society are denied opportunities to reproduce, and it creates internal divisions. So if you have competition between societies, the societies that had this ideology, this belief system privileging monogamy, would do better. And so that's one famous example, I think, of the question you asked, whether cultural products, not material things, but belief systems could reshape trajectory. Another example of this is very famous is the prohibition of cousin marriage. So cousin marriage has been practiced in many societies, different rules about can you marry your second cousins, your first cousins, your matrilineal or patrilineal cousins. You can marry your cousins on your father's side, but not on your mother's side, or on your mother's side, but not on your father's side, and so on. But the decisions to principally with Christianity, to prohibit cousin marriage are also probably similar to that, have had a variety of biological effects downstream. Because when you marry your cousins, I'll say one more thing about this. So probably all of you have heard that marrying your cousin is a bad idea from a genetic point of view. By marrying, I mean reproducing with your cousin. And it's clear because you're more likely to create offspring that are homozygous on deleterious attributes. So why do so many societies do it? Are they unaware of the fact that cousins who reproduce are more likely to produce babies with defects than non-cousins? No, the societies are aware of that. Here's the kicker. It turns out that the cultural benefits of cousin marriage in terms of keeping land together, like when you marry within the family, and wealth together, those cultural benefits might countermand the biological costs. Isn't that a radical idea? In other words, it is the case that I impose a biological cost on my offspring when I reproduce with my cousin, but that cost, such as it is, might be countermanded by the fact that I'm richer. And so I enhance the fitness of my children socially, even as I'm degrading the fitness of my children biologically. So that's another example. Cousin marriage and marriage, they're discussed in the book.
Thank you for this wonderful presentation and your beautiful research. I was wondering if you had any communities or networks that are still thriving that stick out to you as further deserving of research and almost the keys to the answers that you are potentially still looking for within further research, and if those communities are, what sticks out to you about those communities?
So I think what you're asking me is, do I believe that there are some societies in the world that are nicer than other societies? And yes, I think if we're honest with ourselves and with each other, societies vary in how functional they are. And I have to say that you guys in Hawaii have a pretty nice society. Traits in this little subculture that you have that are quite admirable. So I think it is the case, as with any other phenomenon in the natural world, that there's a kind of bell-shaped distribution, and I think we can say that there are certain dysfunctional societies and certain more functional societies. But even though I've said that, what I need to emphasize is, ironically, that's not what interests me. Because I'm not interested in what's different among us, I'm interested in what's the same. Because even in these so-called dysfunctional societies, they still have love, they still have friendship, they still have cooperation, they still have teaching, they still have all these other wonderful things. And it's those things that are universals among us, these good things in particular. By the way, we're also violent universally, right? They're awful things. But today I've been talking about the universal good things that are part of our common humanity. And that's what I'm choosing to study.
Hi. I have a question, and it's actually a comment on what you were just saying. A lot of the evolutionary aspects that people have developed in much smaller groups, smaller societies, because of technology and other things. Our society is just unwieldy at this point, and it's wonderful to be hopeful about the good aspects of people, and I think that that's the way most of the people in this room are. But what we see right now around the world is the negative aspects of our evolutionary traits that seem to rise to the top. And those of us who are loving and cooperative are taken over by the people who are creating the tensions and the schisms. And is this a problem of scale? And if so, can the positive aspects from evolution rise to the top?
So I would say yes to the last question, very directly I would say yes, but let me kind of elaborate or reframe a little bit what you just said. So a good example of this, of the difference would be, our bodies evolved to crave fat and sugar and salt because those things were scarce in the ancestral environment and very good for us. But now in a modern world where we domesticate animals and can go to the grocery store and buy that, it's harmful. It causes diabetes and makes us obese, and the plentiful availability of these foods that we all crave is bad. So the modern world, our bodies evolved for an ancestral environment, and now we've made a new modern world, and unfortunately that's dysfunctional for us. That's an example in our physical bodies. And you're saying, well, Nicholas, what about our societies? We evolved certain traits in our ancestral environment. So for example, we had whatever propensity to violence we had, But now we have weapons, right? We've got powerful, semi-automatic guns that can fire lots of bullets at the same time. Yes, I had a tendency to a certain amount of violence, and I could come and hit you with a stick or stick you with a spear. But now, now I have a machine gun. And so, can we really cope with that interpersonally? Like now, the body example was just in a body. Now we're talking about a social interaction. And you're saying, Nicholas, such as these traits in the social suite are, can they withstand the kind of cultural products we are making now, the political divisions, even the chat GPT and all of these things. And I would say, yes, it can. And furthermore, I would say that the world is not as bad as you think. There's a lot of concern, for example, we are living longer than we did when I was a boy. And actually, there's lower crime rate in the United States than there was when I was a boy. And people have a higher standard of living than we did when I was a boy. And there's less racism than when I was a boy. I mean, we have gay marriage now, which wasn't there when I was a boy. Our society is better than it was. Now, it doesn't mean we're perfect. We've got a lot of work to do. There's more work to be done to improve our society. But it is, in my mind, not a fair characterization to think that it's a calamitous, awful predicament that we are in. And by the way, political divisions, you and I are, I think, about the same age. Do you remember the riots in the 1960s? And the crime rate in New York? I mean, New York has a higher crime rate now than it did 3 years ago, but it's like a tenth of what it was in the 1970s still. So I guess I share your anxiety and your concern, but I'm more optimistic than that. I think we can do it. That's what I think.
So this is going to be the last questions.
You don't have to stop on my account. You just ask the audience.
You hold it. Thank you. Okay, I have a question for you. Thank
It's
you.
up to you. You decide. I'm not gonna. Yes.
Thank you. In this loop where culture feed evolution, the genes, etc., how would emerge personality of an individual, maybe even a violent society, or maybe in a good society, social society like Martin Luther King, Buddha, Karl Marx, Jesus.
Well, one of those is not like the others, but go on. The Buddha, Jesus, Karl Marx.
I know that Karl Marx here represents something. Okay.
So you're asking, I'm sorry, finish.
Yes, please. How do they emerge?
So you're asking, why do we have individual personality differences?
No, in this context of loop.
Why aren't we all pushed to kind of a uniform?
This seems not to be the result of a loop, or it just emerged from where? This is like a deviation from this process of.
The fact that humans have different personalities is a deviation from this loop process?
This type of personality that's so culturally different from the culture they are coming
You mean
from.
why are there some charismatic, distinctive individuals?
So different from.
Yeah, so different. There are always such people, like Mozart, and I mentioned and Newton, and people who are morally gifted. Like I recently watched this documentary about Nelson Mandela, and he comes out of prison after 27 years with not just a shrewd political agenda that we have to forgive, right? Which you could argue that was a smart move politically. This country would have collapsed if it fell upon itself. But I think a genuine kind of moral commitment is extraordinary to be in prison for 27 years and come out forgiving your jailers, okay? So my answer to your question on that is, and also in the other extreme, we have like sociopathic serial killers and other extremes. So there's a distribution in these traits. There's deep theories as to why humans have distributions of traits of all kinds: height, eye color, kidney function, and these personality qualities. And it has to do with the necessary advantages of having distributions. In fact, if we all had the same personality, we would be disadvantaged if the environment around us changed. So there's this kind of natural variation, including in our personalities, and the result of that is sometimes you get very deviant, by which I mean extraordinarily positive deviant individuals.
Oh, hi.
Hi.
Thank you very much. So if I understood correctly, when you were talking about hybrid systems, you had spoken about bots, dumb machines inserted among intelligent humans. What would you say, so that would be narrow AI, artificial intelligence?
Dumb AI, yeah.
Yes. What would you say about general AI, where very intelligent machines are placed among,
Yes.
let's say, not so intelligent people?
Well, my easy answer would be is like, I'm not studying smart AI, you know, so I don't know. I am worried about that, and I think, so I've been thinking a lot about AI. I've been talking to lots of very smart people who do work in this area, which is not my area, and it's like one of those things. You guys remember that scene in Fiddler on the Roof where Reb Tevye is in the village, and one of the guys says something, and he goes, "You're right." And then the other guy says the opposite thing, and he goes, "Well, you're right." And the guy says, "Reb Tevye, they can't both be right." And he goes, "Well, you're right too." That's where I am right now, because I talk to all these people, you know, very sophisticated people that, you know, run Google and this kind of stuff, and they have a wide range of opinions. Some think that we don't need to worry about AI, and others think it's an existential risk, that it's like nuclear weapons, okay? And I listen to the one guy, and I'm like, "Oh, no, he's right, I agree with that." And then the other guy, "Oh, no, I agree with him." So I don't know, actually. But what I can tell you is I am actually deeply worried about the introduction of super smart AI in social systems, especially, as you said, among dumb people, because I think that these tools are going to be rapidly deployed by our enemies to sow division among us. 100%. It's a very powerful weapon against us because we have an open society, right? And we have a freedom of speech in our society. So what's going to happen is there going to be human-like acting divisive agents, artificial agents, that are going to be perfectly calibrated to tell you what you need to hear to hate your neighbor. And people are going to try to do that against us. It's very similar, but much more sophisticated than the Russian efforts to support the NRA so that we arm ourselves. Whatever you think about the private ownership of weapons and how they should be regulated, you probably don't think that the Russians want us to arm ourselves for our own good. They want us to arm ourselves so we kill each other, right? And so we have, but this is, I think, much more dangerous than that. These super. And by the way, however good you think ChatGPT is, in a year it's going to be much better, and in 3 years it's going to be incredibly good. And I think these will become like nuclear weapons. They will be the big models. It costs $100 million now to make a large language model of substantial sophistication. It's going to start costing $1 billion. Only states will be able to do this. It'll be China, Japan, the United States, you know, the G7 countries plus China basically will have these, and they'll be seen as national assets. These trillion parameter models. I mean, literally trillion parameter models that will. I was talking today to someone. You know, there was a lot of worry about how automation. You guys remember, like even 10 years ago, we were all worried about how automation was going to result in working class people losing their livelihoods. Remember, we were worried about like automatic vehicles taking truck drivers' jobs and factories that carpenters were going to lose their work and so on. Well, the machines are coming for me. People like artists and psychologists. I mean, I think we're going to have a bot that can emulate a halfway decent psychotherapist very soon. Like within a year or two, you're going to be able to get, and here's the irony, it might actually be helpful. I mean, you could take 100 people, you could do an experiment where you take 1,000 people, 500 of you talk to a real human and have therapy, you know, once a week for 6 months. And these of you, 500 of you, you get a ChatGPT superpower, perfectly calibrated psychology bot, and you get to talk to them every day for 6 months, and you guys do better. So that's the end of psychology. And by the way, end of professors, end of, you know, I mean, it's an end of all of these knowledge industries, you know, so I'm trying to up my game.
I don't know if you're aware, but in 2017, the female robot Sophia was given citizenship
Yeah, in
in
Japan.
Saudi Arabia.
In Saudi Arabia.
Yeah.
I can't remember if that survived to the final copy of Blueprint, but I think if it's there, it's in a footnote where I talk about people marrying robots. There's another whole topic to be had, by the way, about whether people will feel romantically attached to machines or have sex with machines, a whole other topic. But those things are coming. Thank you very much.